Today I'd like to talk about rate of change, which in other terms, and with term you'll probably be using more or less than rate of change, would be the concept of it being called slope. And a lot of people, slope can be a difficult topic, a hard topic to talk about, but we want to make it a little bit easier. And a concept that you've seen in younger years was that concept that it is equal to is unit rate. Which unit rate, as we know, is taking just the one on the bottom and whatever the top might be. From unit rate, I'd like to jump from unit rate to more of what you're going to see now. Instead of unit rate, what slope is going to be is more of a rise over run. Which is a rise over run, which is a change in y. Change in y over a change in x. Or for really mathematical terms, you'd have, step a little out of the way, you'd have delta y over delta x. But this is just jargon, mainly. It's just a speak that we use. What we have to look at is the concept of what is slope. And slope, we have to sit there and we have to look at more of a graph. And graphically, we'd look at a little easy xy axis. This being x, this being y. And what it is we look at a line. Just say a line coming up like this. If we look at a line like this, we look at it as a positive slope. And it'd be a positive slope because it would go from the left side and it would increase and go up to the right. So if our slope is going, even if we're going at less of a greater incline but still going up, this is still a positive slope. Even if it has a slight incline, we're still looking at a positive slope. So we look at a positive slope, we know left to right going up. So then if we look over here, we draw another easy x and y axis, x, y. We take a look at from going over here up high and going all the way down. Even a slighter, less incline going down. This would be our negative slope. Negative slope. And an easy way to look at that is when if you look at this line, if I was to draw, say, lines off of this, it forms an H. But if I drew lines off of this, if you look very closely, it forms an N for negative, which is an easier way when you're looking at the lines to see if you're dealing with a negative or positive. There's two other special cases that I'd like to talk about other than negative and positive, which let me draw two little graphs again. Once again, we have our xy axis. We have our xy axis. I'd like to just draw a straight horizontal line, and I'd like to draw a straight vertical line. This one right here, it's a flat line. I mean, I drew it to the best of my ability to be flat and not positive. This is a flat line. If it's a flat line, it's not moving. That means the slope isn't increasing, and the slope's not moving. It would give you a zero slope. This right here, special case, and this one right here is a very, very, very special case. And this is an up and down line. It's our vertical line. Our vertical line gives us an undefined slope, which will later on means that we have something in our y value, but our x value is 0. Because if you have x in our denominator, we know that we get the undefined at this point. So let's actually take a look at how we can form these lines. How can we make these lines? Because so far I've just been drawing lines on a whiteboard and not done anything impressive. What I'm going to look at now is what we call the slope formula. And the letter that we use to represent slope, and this is very, very important, is M. To be honest, to this day, have not researched why it's M, but it is M. And remember that for later on, for later lessons. But m, and what it is, the slope formula gives you y2 minus y1 over x2 minus x1. Now I don't want these down here to be confused with exponents. They're actually subscripts, just used. And what it is I'm going to take two ordered pairs. Ordered pairs. And I'm going to take these 2 points and I'm just going to make it, say, point A. And this will be -1, -4. And I'll take point B, which is 2, 2. And these are the 2 points I want to first work with. So what I'm going to do is I'm going to put them up here so they're out of our way. And I can actually work with them, because I've almost taken up most of my little whiteboard. A and B, and now I'm going to erase myself, leaving my formula but getting the ordered pair out of the way. And I want to look at my formula now. My formula has only 2 letters in it. It has X and it has Y. And what we know about ordered pairs is it gives you an X, comma Y. So, now you actually can figure out what that subscript might mean of the 2 and the 1. I'm going to make A our 1's and B our 2's. So that means where X is, this right here would be our X1 and this would be our Y1. And where X is here, this would be our X2 and this would be our Y2. So all we're going to do now is a normal just plug into a formula. So I'd have equals, so where's my Y2? My Y2 is for B, B for Y is 2. And I'd subtract that from my A, which is my Y1, which is -4. Put that in parentheses. And we look now at our X. Our X2 is B. And we're going to subtract that from our Y1, our X1, which is A, which is -1. Now there might have been different ways that your teachers have shown you or different people have shown you to do 2 minus a -4. But we're going to do a little easy thing. And when you see 2 minus signs in a row like this, I mean, I can go in depth on how to really speak about why this does this, but all I want you to do is if you see 2 minus signs, you make them plus. And 2 plus signs look silly. So 2 plus 4 on top, and 2 plus 1 on the bottom. Well, 2 plus 4 is 6, 2 plus 1 is 3, and we know that if we simplify this, we would get 2 over 1. The thing about slope is we want to keep it in fraction form. We don't want to change this 2 over 1 to just be 2. Because if we remember back right in the beginning of the video when we spoke about slope, the slope equaled rise over run. So what does that mean? We can erase this now, which if you're copying, you've copied. If not, you can always rewind the video. We erase this and we keep our 2 over 1, which equals slope. And now, I mean, for myself, I advise you to get grid paper. I'm going to try and draw myself the best XY axis I can on a whiteboard with no ruler. So I'm going to have 1, 2, 3. What point do I have to go? I have to go to -4, so 4. I mean, it's not perfect. So our first point, our point A, is -1, -4. So -1, and they go down 1, 2, 3, 4. And this would be our point A. Our point B is 2, 2, which is 2 in the X and then 2 up. So I go 1, 2, 1, 2. This would be our B point. And once again, I'll have to be very careful and draw my line the best I can. And I'm going to put arrows at the end because this line can go on forever. Because if I look at my slope, and it says 2 over 1, if I go 2 up and 1 to the right, rise over run. And that was something I didn't say, but should have been said in your previous class. Run, you're always running right. You stay with the R's. And I'm rising, I mean, I could rise, it's a positive, so I'm rising in the positive direction. and it's positive on the bottom, so I'm running to the positive direction. So if I go up 2, 1, 2, and I rise 1 to the right, my line is almost right there. I mean, I did a best fit line to the best of my ability. If I go 2 up and 1 to the right again, 1, 2, and 1 over, I'm still on the line. If I go up 2 to the right and 1 over, I still get to B. But what was that original point? The original slope I had before I simplified was 6 over 3. If I go 6 up and 3 to the right, I bet you we get B. And let's see. 1, 2, 3, 4, 5, 6. And I'm going to run 3 to the right. 1, 2, 3. So this slope of this line is 2 over 1. But any multiples of 2 over 1, such as 6 over 3, or even 4 over 2, these are all equal, and these are all the same exact slope, because a simplified form is the same number. Because 2 over 1 is 2, 4 over 2 is 2, and 6 over 3 is 2. So if I follow this up, and let's do 4 over 2, just to check, just to be sure. 1, 2, 3, 4, and 1, 2, I'm back at this point. So we kind of see what slope is, what's the importance. We can draw a line. We can draw a line without doing that function table, or the input-output table, depending on what your teacher had called it. But let's take a look now, because I've mentioned the input-output table. Let's say I'm not given ordered pairs like I was up here. I'm not given it. I'll erase the whole thing. The only thing I want to rewrite is the formula. I'll write it in this top corner. y2 minus y1 over x2 minus x1. Okay, that formula, that is the slope formula. There are other formulas that we're going to use that have the word slope in it. Probably not in this video. But in other videos later on, we'll be talking about other slope formulas. There's a point slope, but we're not going to talk about that right now. We're going to talk strictly about this slope formula, which is y2 minus y1 over x2 minus x1. And these are not exponents. So let's take a look at a chart. Let's take a look at a simple XY input-output chart like we used to do in 6th grade and 5th grade and our elementary years, and we'd have to solve everything and do all this work. 0, 9, 2, 4, 4, negative 1, and 6, negative 6. So once again, we're given x and y. Now if we think back to our, I would say science courses, we would talk about independent and dependent variables. Which you have to realize that your x is an independent variable. Independent variable. And our y is a dependent variable. So just in case you're given a chart that doesn't have x and y, you would still understand that your independent variable is your denominator, and your dependent variable is your numerator, which means the variable that you put into, say, a function or within your function table, and you get that next value, that dependent variable, you would know how to find that slope. But that's the independent dependent. I just wanted to speak about it. I'll touch base on that a lot more later on, maybe in a different video. But we're going to stay just general about talking about this slope formula and all the different uses I use this slope formula for. So let's look at this one. And I don't have a set, I mean these points are in order, but I don't have a set of which one is going to be my x1 and which one's going to be my x2. Hint, doesn't matter. I could make this my x1 and this my y1, and I could make this my x2 and this my y2. I could have picked these two, I could have picked these two, I could have picked the top two. I would have gotten the same slope. So what I'm going to do is now I'm going to plug it into the formula. So I'll get negative 6 for the y, and then I go to y1 minus 4 over, well, I have 6 minus 2. Once again, I'm working with sign numbers. And I have a negative 6 minus 4. And I don't know how your teacher maybe had you think about it. You thought about it as a negative 6. I'm minusing 4 from it, so it becomes a bigger negative. But what I like to do is when I see a negative minus a positive number, I like to make it I'm adding 2 negatives. It's the same concept, and if I have to, I'll make a sign number video to really talk about it if I have a lot of complaints. But that's something that I can explain using the negative numbers, using the sign numbers, but I'm not going to go in depth now because if we're working with slope, you've already worked with sign numbers and you have your own way of solving it. This is just my notation for it. But a negative 6 plus a negative 4 is a negative 10. And a 6 minus 2 is 4. Well, negative 10 over 4, let's simplify it because slope, I would rather it in simplest form. Well, we can divide a 2 out from top and bottom. I get a negative 5 because negative 10 divided by 2 is negative 5, and 4 divided by 2 is 2. Well, negative 5 is a prime number. It's an odd number. Can't be simplified. So this is our simplest form. So what I want to do real quick is I would like to prove to you that it doesn't matter which points I pick. Doesn't matter at all. But I'm going to make this my x1, this my y1. So let me just x these out so we don't get confused. And I'm going to make this up here my x2 and this my y2. I want to prove that no matter what points I use, as long as I plug them in the right place, it doesn't change the answer. So this time my y2 is 9, and my y1 is negative 1. So I've got minus negative 1. Over, my x2 is 0, and my x1 is 4. Minus 4. Well, once again, I've got the double negative, and I like to put 2 plus signs then. So that just means I've got 9 plus a positive 1. So that's 10. I got negative 10 up top. Doesn't look like my theory was correct. But 0 minus 4 gives you a negative 4. And the thing about this is you have a positive and a negative number. And a positive and a negative number when dividing, if you have 2 opposite signs, your final answer is negative. So once again, I'm going to divide by that 2, because I can. And I'll get 5 over 2, and I'm going to put the negative symbol in the middle. Which up here, if I change it, you could put the negative symbol in the middle. It's the same slope. As long as I make sure my x2 is below my y2, and my x1 is below my y1, my points, my slope will come out correct. So now we've talked about tables. We've talked about ordered pairs. So let's take a look at a graph. And I mean, technically, when you look at ordered pairs, you're looking at a graph. But let's take a look at one more ordered pair. And I'll save the graph. I'm just going to go to an ordered pair. And I'm just going to take 5, 4, and I'm going to make that my point B. And I'll make my point C negative 12, 6. I made 2 random points. And any 2 points can form a line. So that means any 2 points can have a slope. So let's use our slope formula. Our slope formula being m equals y2 minus y1 over x2 minus x1. So let's plug it in. Well, this time I'm going to make this my 1s. So I'll make this x1 and this y1. And I'll make this x2 and this y2. Alright, so let's plug it in. Can't be that difficult. Well, my y2 is up in my top left corner, so 4 is in my top left corner. Minus my y1, which is my top right corner, which is 6. That's this and this. Check and check. So let's do my x's now. My x2 is 5. Okay, so I got that out of the way. Minus a negative 12. I put my negatives in parentheses so I don't mix them up with my minus sign. Well, I've got the double negative again, so I write 2 plus signs. So if I wanted to, just to say, not to save room, but to actually show it, all I'm really doing is this. So 12 minus, not 12, I was looking at 12. 4 minus 6, well, that's a signed number, that's a negative 2. 5 plus 12 is 17. Well, I can't simplify 17 because it's odd and prime, and 2 is even. So this would be our slope. And that would be it. That would be our answer. If we're given 2 points to find slope, that's all we're working with. And as we saw in the other one with the table, maybe I'll do just one more table example real quick. I'll do one more table example just real quick. Give the time. So I showed them 4 examples. So let me show a table real quick. Let me show you, make it hard. We'll do X. I'll make it this way this time, Y. And I'm doing prices maybe. I'll do 10, 15, 20, 25. Okay. So then let's use decimals, because no one likes decimals. We have 70 cents. We'll do $1.05. We'll do $1.40. And our final one, we'll do $1.75. So it doesn't look like it's increasing in any real manner, but it doesn't matter because our formula, which once again is M, equals y2 minus y1 over x2 minus x1. I just have to pick which I'm making 1 and which I'm making 2. I'm going to stick with the 10s, the whole numbers, the 10 and the 20, and not worry about the 5s. So I'll make this my 1 column, this my 2 column, meaning this would be my x1 and this would be my y1. This would be my x2 and this would be my y2, as I follow along the line. So let's plug it in. Well, my y2 is $1.40 minus my y1 is 70 cents. Line. My x2 is 20 minus my x1 is 10. Well, $1.40 minus 70 cents is only 70 cents. And 20 minus 10 is 10. Well, the good part about this is I can actually divide 10 into both of them. So 70 divided by 10, 0.07 over 1. This would be our slope of this. And if I use 15 and $1.05 and 25 and $1.75, it would be the same. If you want to check it yourself, you can. I'm not going to because I feel like I've killed this slope formula enough. Until the next video, I will hopefully be able to answer any of your comments or questions. If not, hopefully this video helped you.